We are continuing part 2 of the recording on slide 9. So we are still busy with matrix multiplication, and here is your first example. This is a very straightforward example. So here you have a row vector, and this row vector is for price. So we'll use the symbol P and its lowercase to represent that it is a single row, hence it is a row vector. And here we have quantity Q, and it is a column vector. So you have a single column, hence column vector. Now you know that total revenue is given by the product of price times quantity. So if we take this row vector and we multiply it by this column vector, we are saying price times quantity, and what that will yield is an answer for total revenue. So first of all, we always need to check the order. Remember, M by S and S by N. That needs to be the order. The columns of your first matrix must be the same as your rows for your second matrix for which you're wanting to get the product. So if we look at P, this row vector P, it has an order of 1 by 3. Remember, we always say rows by columns. So it has one row, but it would have 3 columns. And if we look at this column vector for Q, Q has an order of 3 by 1. 3 rows, but 1 column, hence a column vector. 1, 2, 3 rows, but 1 column. So these two middle numbers are the same. So therefore, this matrix multiplication will work. And very importantly, the answer, total revenue, is going to have an order of 1 by 1. 1 row, 1 column. So how do we go about this multiplication? So here's my row vector and here's my column vector, and I'm going to get the product thereof. So you're going to take this first element in your row and you're going to multiply it by the first element in your column. And then you're going to add it to the second element in your row to the second element in your column, which is 30 times 200. Then you're going to add that to the third element in your row to your third element in your column. And that is 20 times 175. So you're always taking the element in the one matrix by its corresponding element in another matrix. And then you add these together, and what you are yielded is your total revenue. And this is simply one row, one column, as you have over here. So this is the simplest form of multiplication, but it will get a lot trickier, as you will see over here. Now here you have matrix A and matrix B. And these are both square matrices because the numbers of rows and columns are the same. 2 rows, 2 columns, 2 rows, 2 columns. So if I want to get the product of A and B, as we have here, I can see that my rows by columns and rows by columns, the two numbers in the middle are the same. So therefore my answer C is going to be matrix C. It is going to have an order of the outer numbers. So it's going to have a 2 by 2 order in terms of the answer. So let's do this multiplication. So here you can see I've got matrix A over there multiplied by matrix B. And this is just telling me what I'm doing. And this is going to give me matrix C over there. So how do I get from here to here? So first of all, you need to think very clearly about what you're doing. This entry or element, right? It is in row 1, column 1. That is its address. So in order for me to get this, I need to take my row 1 by my column 1. Have a look again. This is in row 1, column 1. So therefore, in order to get it, I need to take my row 1 in matrix A times my column 1 in matrix B. So therefore, 1 multiplied by 1 plus minus 1 multiplied by 1. This is this portion over here. It is going to give me that answer of 0. Next, let's look at this element. This element is in row 1, column 2. So therefore, I need to take a row 1 of my first matrix by column 2 in my second matrix. So therefore, you always take the corresponding element. So therefore, my first element in this row multiplied by my first element in this column is going to be 1 multiplied by 3 plus my second element in this row multiplied by my second element in this column minus 1 multiplied by 2. And that is this portion over here, and it will yield an answer of 1. If we have a look at this element over here, it is in row 2, column 1. So therefore, I'm going to take my row 2 in my first matrix and multiply it by column 1 in my second matrix. So therefore, 2 multiplied by 1 plus 1 multiplied by 1, that is this portion over here, is going to yield this answer. And lastly, this element or entry is in row 2, column 2. So therefore, I must take row 2 of my matrix A, that is this row, and I must take column 2 of my matrix B, and you always take the entries that match. So this is my first entry, that's my first entry in this row, and that is my first entry in that column. So 2 multiplied by 3, which is that, plus my second element in this row multiplied by my second element in this column. So 1 multiplied by 2. And you add that, and it's going to give you an answer of 8. So there you've got your answer for the product of matrix A times matrix B. It gave you matrix C. Now, remember the commutative law that does not apply in matrices? Here, it can be proven. If we get the product of matrix B by matrix A, what we get is matrix D. And of course, you would have checked the orders to see that it first of all is possible. So you can see that we've swapped these two around, or they've commuted. We first have matrix B and then we have matrix A, but it is not going to yield the same answer. These two answers are not the same. Matrix C is not equivalent to matrix D. So this just proves that the commutative law does not apply with matrices, only with some few exceptions. Now, if we have a look at the product of matrix B times matrix A, again, you are going to determine which rows and columns to multiply by each other. So I always look at the address of the elements that I'm going to find. Now I know that by checking the orders, matrix D must have an order of 2 by 2. Remember the two inner columns and rows, those two numbers were the same, so therefore the order of D is given by the outer numbers. So it must have 2 rows and 2 columns. So therefore, if I look at this element is in row 1, column 1. So therefore, I must take row 1 by column 1 to get that answer, right? And if I want to get this answer, this element, and the answer there was 2, it is in my first row, but it's in my second column. So therefore, you take your first row by your second column in the other matrix. So let's just quickly do that one. I would say 1 times minus 1, which is that portion over there, plus 3 times 1. And that is going to give me minus 1 plus 3, which gives me 2. And if we look at this final row in this matrix D, so this element of 5 is in my second row but first column. But how did I get that? In order to get that, I took my second row by my first column. So if I say 1 times 1 plus 2 times 2, that is this portion over here, see, it's going to yield an answer of 5. And then lastly, this element is in my second row, second column. So therefore, I need to take my second row by my second column to get this answer. So therefore, 1 times minus 1, which is that, plus 2 times 1. So that is going to give me minus 1 plus 2, just gives you an answer of 1. So I hope that you follow matrix multiplication. It isn't difficult, but it can be confusing. So you need to think about which row by which column is going to yield the element in your final matrix, which is your solution. Here's another example. So I'll take my time to go through it. You've got matrix A times matrix B, and you're going to get matrix C as an answer. So here, let's check the order. I have 1 row, 2 rows by 1, 2, 3 columns. So that is my order for matrix A. Matrix B has 1, 2, 3 rows by 1, 2, 3, 4 columns. So it is a 3 by 4. Notice these two are the same. So therefore my answer C must have an order of 2 by 4. I take the outer number over there and the outer number over there. So you could even draw your brackets and then have spaces for 2 rows but 4 columns so that you know the entries that you are going to get. So therefore, if I do this multiplication very quickly, I'll just do selected values. Let's say I want to get this number 2. So this is in the first row, but it's in my second column. So therefore, I'm going to take my first row by my second column. And of course, I must always take the corresponding elements, the first element with the first element of the other matrix. So therefore, I'm going to take 2 times 1 is going to be 2, plus 1 times 0 is just 0, and 0 times 4 is just 0. So therefore, if I sum those three values, it's 2 plus 0 plus 0. I'm just going to get an answer of 2. So that's just one example. See that if you test yourself, can you obtain all these elements, which is given by the product of matrix A times matrix B. So this is just a summary of your matrix operations. From last week, you dealt with addition and subtractions, and then we started with our scalar multiplications this week, and then you looked at various laws, and then finally your general matrix multiplications. So I'm going to stop at this point and we will continue with the next set of slides on slide 13.